In this video, I'm going to explain the absolute basics of what a PLC or programmable logic solver is, hopefully in a way a complete beginner will understand. Let's take it back to the basics of what a logic solver is. In engineering systems, we have inputs and outputs. Inputs are the variables the system is monitoring and reacting to. Outputs are the final elements or components that act on our system. Here we have a basic electrical circuit. We have a battery providing power, a switch as an input, and an LED which is acting as an output. If we manipulate the input by closing the switch, then the output changes state and the LED illuminates. If we open the switch, then the LED goes off again. This logic can be written in something called a truth or logic table. Let's draw a truth table for our circuit. Here we can compare the logic of our system looking at the inputs on the left and the outputs on the right. We can see here the logic we just saw in our circuit. Let's expand on this logic idea and look at other configurations. If we had multiple switches, we could change how they act on the output or LED with the wiring configuration. Let's say we want to have a circuit where you need to press both buttons to illuminate the LED. If we close a single switch, the output stays off. If we open switch 1 and close switch 2, the output will also remain off. Only when we close both switches does the LED illuminate. This is called AND logic. Let's draw the truth table for AND logic. Here we can see the only input configuration that gives us an illuminated LED is both switch 1 and switch 2 are on. Now let's suppose instead of wanting both switches pressed for the LED to be on, we want our LED to illuminate from either switch. To do this, we would have to change the configuration of the wiring. In our new OR configuration, when we close switch 1, the LED illuminates. If we close both switches, the LED remains illuminated. As you can see, only when both switches are broken is the LED off. This is OR logic. Let's quickly draw the logic table for the OR configuration. On the table, you can see the logic we just discussed, where either input being on will cause the output to be on. Anytime we want to alter our system logic, we would have to physically rewire the circuits. In complicated systems with numerous inputs and outputs, this can be tricky and time consuming. So we developed programmable logic solvers to do the work for us. Here we can connect the inputs and outputs to our PLCs, with as many inputs and outputs as we want and the system can maintain. The PLC runs software that controls the logic however we choose. To change this logic, it's simply a case of connecting to our PLC with a laptop and changing our logic. Hopefully you now understand the basics of logic and why we need PLCs. In the next video we will talk about the hardware configurations of PLCs. Make sure you subscribe for future parts of this series. Check out my other videos for other instrumentation and control related topics.